everyone. Let me introduce myself. My name is Dasnishwaran and I'm going to present you guys about hydrostatic pressure acting on a partially and fully submerged surface. Introduction. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or in the fluid's potential energy. The relation among the velocity, pressure, and elevation in a moving fluid, gas or liquid, the compressibility and viscosity, internal friction of which are negligible, and the flow of which is steady and laminar is indicated in Bernoulli's theorem. The first of these, when applied to a liquid flowing through a conduit, requires that for steady flow, the velocity will be inversely proportional to the flow area. The second requires that if the pressure must decrease when the velocity increase. The objective is to investigate the validity of the Bernoulli's equation when it is applied to a steady flow of water through a tap duct. Methodology. To measure the total head and pressure head at the known points along the flow. In this experiment, the validity of Bernoulli's equation will be verified with the use of tape duct, which is known as Venturi system connected with manometers. Procedure. First, the venturimeter was placed onto a horizontal surface and make sure the height of the input valve and the output valve are the same. Then, the apparatus were attached with the power supply and make sure to keep the supply off and open all the air bleed valves of the manometer present at the top. After that, run the pump by switching on the power supply and adjust the flow rate control valve until water level in the manometers are readable range. Then, place a stop plug in basin and then take note of the time required to fill the basin with specific amount of water. Place the dynamic pressure probe with the static pressure port after removing the stop plug to drain out all of the water and then measure the manometer data from both of the probes. Place the dynamic pressure probe with the next static pressure probe and measure the manometer data from the probes and repeat the above steps by measuring data from the manometer probes. Finally, switch off the pump and turn off the power supply. The results. The result shown by the manometer is the sum of velocity and the pressure heads, the reading in the manometer measured by the pressure head only. There will be a small loss of head due to the friction within the fluid and between the fluid and the walls of the passage if the fluid is not inviscid. The area reduced, then the velocity must increase. In a diverging duct, as the area increases, then the velocity must decrease for an incompressible fluid flowing in a converging duct. These are the results. And the graph. And conclusion, to conclude, it is proven that hydrostatic forces are resultant forces caused by the pressure loading of a liquid acting on a partially for fully submerged surface. It is proven that Bernoulli's equation is a valid theory. This is because pressure throughout a tube should stay constant regardless of the cross-sectional area of the tube as shown in this experiment. Besides, if the fluid is flowing from a wider to a narrower tube, the velocity of the fluid will increase and vice versa, regardless of the pressure difference and the type of flow. The objective of this experiment has been achieved. Thank you.